The Charter Podcast, Episode 12. Code Red for Humanity, Part 4. Peatlands as Nature-Based Climate Solutions, with Professor Graeme Swindles of the School of Natural and Built Environment. Hosted by me, Maurice McCartney. Throughout this series, we've been looking at the IPCC report and how to make the transition from fossil fuels to clean power.
I think in the last year, despite COVID, where there was a big market depression, we've seen one of the biggest uplifts in EV registrations this year to date. So there is huge growth starting to be seen in that sector.
So, offshore wind is going to play a huge part. Actually, probably the British Isles could probably supply maybe 30% of electricity needs to the European Union. And I think for us in Northern Ireland, that's a great opportunity.
But of course, clean power is only one part of the picture. The other side is how we draw down the carbon that's already in the atmosphere. So for this episode, I'll be talking to Professor Graeme Swindles about peat.
So I'm Graeme Swindles. I'm Professor of Physical Geography in the School of Natural and Built Environment in the Geography Department. And I'm a physical geographer, so I'm interested in planet Earth in terms of the Earth systems. I'm also an Earth systems scientist, so I'm interested in the interactions and the feedbacks between different parts of the Earth system. In terms of my research, one of the big interests for me is how do ecosystems respond to climate change and that interaction between the biosphere and climate change. That's led me to be very interested in peatland ecosystems and how peatlands are responding to climate change and how they will respond in the future, and also how they've responded in the past. Peatlands only cover about 3% of the global land surface, but contain up to 40% of all the soil carbon. So that's a lot of carbon, and we need to understand what will happen to those with that carbon stock under changing climate.
I suppose people are pretty familiar with the idea of forests and trees and woodlands as carbon sinks, but maybe they're a bit less familiar with the idea of peatlands and even soil as such as performing that role. How do we get our heads around this?
I think it's a really good point, Maurice, and I think a lot of people don't quite understand just how much carbon there is in peatlands around the globe. So as I say, only 3% of the land surface is peatlands, but we find peatlands, the Arctic is full of peatlands. We've got enormous areas of peatlands in Hudson Bay, lowlands, sort of that bit in Canada, you've probably seen on the map, Western Siberia, enormous areas. We've also got peatlands, of course, here in Ireland. We've got peatlands in Europe, but we've also got peatlands in the tropics. And big centres of peatlands are under the Amazon basin, Western Amazon, also under Congo, rainforest as well with peatlands there. But to put these numbers a little bit into perspective, so peatlands contain about, it's a bit of debate about this, but about 550 gigatons of carbon, and that's far more than in the world's forests. That's probably twice, something along in that order of magnitude, than in the world's forests. Since the end of the last ice age, peatlands have been locking down this carbon. So the plants that grow on the peatlands through photosynthesis, they're pulling in carbon. This carbon is then getting buried underground. So they're true carbon sinks. Carbon's getting locked away. Whereas if, forests are brilliant, they're important carbon sinks and stores. But if the tree dies, that carbon gets released to the atmosphere again. But peatlands are actually locking it and pulling it underground. But I said, peatlands contain about 550 gigatons of carbon. And since the last glacial maximum, peatlands have sequestered about the same as amount of carbon that there's in the atmosphere. So it's a really quite enormous amount of carbon.
Pretty extraordinary figures. And I guess even people who are interested, I'm interested in these issues. And it's only very recently that people have started talking to me about peatlands, and so that's, now I see why.
Yes.
In terms of Northern Ireland, we, as you said, have some peatlands. How much have we got, and what kind of condition are they in?
Yeah, no, I think it's again, it's very interesting. I actually did my PhD on the peatlands of Northern Ireland and visited quite a lot of these sites. We've got plenty of peatlands in Northern Ireland. I don't actually have a figure for the carbon stock, but we can find peatlands in the uplands. We can find blanket peatlands in the Antrim Plateau and the Sperrins, parts of Fermanagh. We've got lots of raised bogs and fens in the lowlands. So certainly the north of Port Glenone and that sort of area, and we've got lots of raised bogs as well. County Tyrone over near the Ferry Water Bogs, lots and lots of raised bogs there. And around here where I live in County Down, we've got lots of fens, all those little drumlins, all those hollows, an awful lot of those. If they're not lakes, they're fens, they're peatlands. So we've got lots of peatland in Northern Ireland. The problem is that some of this peatland has been heavily damaged. So there's a long history, of course, of drainage of peatlands for land improvements, also cutting peat for fuel, and also burning some of these sites as well. So one of the issues is that when we damage these sites, when we drain them, when we cut them, when we burn them, we can actually change them from sinks, carbon sinks, into sources, and they can be releasing a lot of carbon. I'll give you a little figure here that globally damaged peatlands contribute to 10% of greenhouse gas emissions from the land use sector. So I can't give you a figure for Northern Ireland for that at the minute, but globally, this is a major problem and we need to do something about it.
Yeah, so that's quite a sort of an alarming, I suppose, prospect. I guess that obviously there's going to have to be a global effort to try to draw attention. Again, it sort of links to what I was saying before, because probably most people don't realize that there is a big problem, but it's such an important resource, performs such an important function, and therefore that the depletion of these things is so important.
I think that's right, and even putting carbon to one side, peatlands are very important for other reasons. They're incredibly important habitats for plant life, for invertebrates, for animal life, for birds. They also provide a record of the past. They're like time capsules. We can take samples and find out what landscapes and what climate was like in the past as well. So these are really important ecosystems. They also are very important for slowing the flow. We're all very concerned about flooding, and peatlands are very important in terms of slowing the flow and potentially decreasing flooding downstream. So there are lots of these ecosystem services, as we call them, that they're important. So peatlands can be considered as nature-based climate solutions. They're going to, they're a nature-based solution to climate change. They're not going to, we need to cut emissions as well. That's most important, but these are going to help us very much along the way. If we can stop damaging them, try and restore them and look after these ecosystems.
Just to get a sense of the kind of richness of the word biodiversity almost sounds a bit too clinical, doesn't it? But in terms of the wildlife and the life under the surface there, I was looking at some of your research output, and I noticed you're looking at amoeba yes, and that sort of thing. I was thinking, let's talk amoeba.
Oh yeah, that sounds great. Yes, I love amoeba. So I'm interested in these little creatures, a single-celled organisms called testate amoebae, and these form a little shell, and so incredibly simple, one cell, and they've got things that they put out called pseudopodia, wonderful name, false feet, and the thing about these testate amoebae is they're very important indicators in peatland. They can tell us about how wet or dry the peatland is, and they can also tell us about, if the peatland has a lot of nutrients or less nutrients in it. And we're using these things as indicators. And we're using these things as indicators and trying to think about how peatlands have changed through time and how they may change in the future. For example, some of the work we're doing in Arctic ecosystems, we're looking at cores we're taking through these from the very tops of these peatlands, and we're looking at the testate amoeba, and they can tell us about how the hydrology has changed on this. And this is really interesting because it's telling us that a lot of these Arctic peatlands that contain permafrost, that contain ice, are melting, and actually some of them are drying and some of them are melting. The whole mosaic of these peatlands in the Arctic is changing. So these tiny creatures can tell us quite a lot about environmental change and allow us to go back in time and in areas where really there's been very little observations.
They're useful for getting a record of the past, but I guess the other side of these things is always that there's a kind of an interdependency in the natural world and in the living world, as it were. So I mean, I presume also the likes of those tiny microorganisms are also a food source for bigger organisms, which then become a food source. And so that there's that whole sort of cycle. I'm thinking in terms of the life of the soil, because obviously we're in the run up to COP26, so a lot of people are thinking about climate, but environmental issues go beyond just climate as well. I presume there's also a dimension of the interconnectedness of all of these creatures, and therefore the soil, and therefore, because we're not separate from nature.
Yes.
We seem to think we're the only creature that doesn't need a habitat to live in.
Yes, yes. I think it's a really good point, Maurice. That it isn't just carbon. Certainly it's one of the really important things. But when we're changing these ecosystems, when we're changing the eco-hydrology, the relationship between hydrology and ecology, it has wider knock-on effects for these ecosystems. And I'm thinking about some of these little raised bogs. I say little, they're relatively small on a global scale, but in places, for instance, in County Tyrone, and these are little spots of wilderness within quite heavily used agricultural landscapes at times. So really important habitats for invertebrates, for birds, for all sorts of things. And when we damage these systems, we remove that, and we remove that from the landscape, which is really very alarming.
So I suppose the question then, leading on from that, is what are we going to do about it? What can we do to change the way the practices, and indeed the politics? I guess if you were able to sit down with environment and agricultural ministers and so forth, what would your policy asks be?
Yeah, I think it's a really good point, Maurice. And I'll give you a little quote from a paper we did here. I'll give you another fact and figure because and this is a paper we wrote last year, and we suggest in this paper by 2100, 100 billion tons of carbon could be released from peatlands, and that's equivalent to 10 years worth of emissions from human activity. So it's a serious amount of carbon, and what we need to do with these peatlands is we need to understand them. So that's why people like me are trying to work on these peatlands, try and understand how these ecosystems work, the feedbacks that are inherent in these things. So that's the first thing. But there's clear things we need to do. We need to, peatlands that have been drained, we need to block these drains. So there's great work ongoing in Northern Ireland from different groups. I'm involved with work with Ulster Wildlife, who are doing great work restoring some of these peatlands. So the drains that have been put through the peatlands need to be blocked up, make the peatland wetter, so that when the plants die, they will fall into a condition where they won't completely decompose. The wet conditions will allow them to make peat. In a sense, we need that. So drain blocking is very important. Other things we need to do is, unfortunately, we need to stop cutting peat for fuel, and we need to stop cutting it for garden compost. It's crazy, and there's nothing like a pint of Guinness with a turf fire. I know that it's got a very emotive smell and things like that, but really there are other things that we need to do. We need to preserve these things. As for peat as garden compost, I'm a gardener myself, and peat is really not a very good thing to use in the garden because A, it's very nutrient poor, B, it's got funny hydrological properties, and that when it dries out, it can sort of form a crispy surface. We call it a hydrophobic surface, and then more water doesn't go into it, it runs off. So it's far better to make your own compost, and there are better alternatives out there. So we need to move away from that. Other things then we need to think about is certainly if we move to tropical areas, so for instance, Southeast Asia, enormous areas of peatlands and peat swamp have been damaged there. They've been converted to agriculture, an awful lot of which is for oil palm. And we see palm oil in lots and lots of products, makeup. The children had flapjacks the other day, and I noticed there was palm oil in them, and they're in so many different things. So I think as consumers as well, we need to think about what we're buying and the impacts of these things on peatlands globally. The other thing as well, fire is a big issue in peatlands, and that's something that we need to stop as well. Certainly in certain areas, peatlands are actually managed through fire, and the majority of evidence suggests that this is not good for these ecosystems, and it isn't good for the long-term carbon balance. There's a better way to manage the uplands. I'm thinking about Northern England, the moorlands, and this sort of long history of burning, and also parts of Scotland as well. There are better ways to manage the uplands. But really, the bottom line is we need to keep peat in the ground, and we need to keep these peatlands wet as much as possible and respect these ecosystems, because they're going to help us along the way in terms of future climate.
Sounds excellent advice. I guess I'll have to try to talk to some people, some of your colleagues, maybe over in the politics department, and see if we can work out ways to present these policies to the decision makers.
Yes. Well, no, I suppose the only thing worth to say, if anybody's interested in peatlands and finding out more, they can always get in touch with me, because I'm happy to talk about peatlands with anybody. It's they're fascinating ecosystems.
You've raised the issues of some policy issues, so I'll maybe try to talk to some political scientists and some of our colleagues on that side of the house to think about these things. But certainly, in the meantime, I'm sure if you mentioned a couple of the environmental groups in Northern Ireland, I'm sure you'd be happy enough for people to contact you if they need advice on these things. So
I'd be delighted to, Maurice. And we're doing lots of interesting work in the peatlands of Northern Ireland. I've got 2 new PhD students that have just started, and we're doing lots of fascinating things. So if anybody is interested in getting in touch in discussing some of these issues, I'd be delighted to speak to anybody.
Very good. Well, we'll put the links in the on the podcast and on our website, and hopefully start to build a little network, but like the fibers of the peat itself, perhaps.
Sounds good to me, Maurice.
So in the meantime, Professor Graeme Swindles, thank you very much.
Thank you very much indeed.
Many thanks to Professor Graeme Swindles of the School of Natural and Built Environment. Follow us on social media at QUB Engagement, and for more in this series, visit our website go.qub.ac.uk/charter-podcast, or subscribe to Queen's University Belfast, the Charter Podcast, on all the main podcast platforms.